Hello, in this video I will demonstrate to you how to configure and use DMA multiplexer with request generator usage. Prerequisites for this session. I will use Nucleo C031C6 board, which will be connected to our PC with micro USB cable. And then from software point of view, I will use STM32Cube IDE in version at least 1.10.1 and STM32Cube library in version at least 1.0.0. Here on the screen we can see as well the blue button which will be used to generate an external signals as it is connected to PC13 pin in our microcontroller. Example description. On the left part of the screen we can see the block diagram of our application. We will use an external interrupt on PC13, our blue button, timer 14 working in PWM configuration without output signal generation, and USART 2 which is connected to ST-Link as virtual COM port on PC. Each blue button press generates a synchronization signal on the DMA multiplexer, which is triggering a single DMA transfer from Pulse's SRAM buffer to timer 14 prescaler register, changing its effective frequency. Then on its output compare signal, so in the middle, this timer 14 is triggering DMA multiplexer once again using its synchronization signal, which is triggering another DMA transfer, this time from TX buffer to USART to transfer register, character by character. So it will be visible as a single letters displayed on the terminal. Bit more details concerning our target application. Timer 14 is configured in PWM mode, initially 10 Hz frequency, 50% duty cycle. Prescaler of this timer will be changed among predefined values on each blue button press. As timer 14 has no direct connection to DMA, we will use DMA Request Generator 0 to perform such a connection. Blue button press generates external interrupt on line 13, which triggers a single transfer between SRAM and the timer 14 prescaler register using DMA Generator 0. USART 2 is configured in asynchronous mode on PA2 and PA3 pins, which are connected to onboard ST-Link, and this interface should be configured as 115,000 bits per second, 8-bit data, 1-stop bit, and no parity. USART 2 additionally uses DMA to transfer data from another SRAM buffer called TX data or TX buffer, to transmit character by character one string to the terminal output. Each output compare event from timer 14 generates such single transfer of the character from the buffer to the USART to transmit register. Changing timer 14 prescaler causes change of the simple message string display speed. I'm opening STM32Cube IDE. My location is this one, so I just click launch and create a new STM32 project. Okay, our target microcontroller will be C031C6. We can see the board already, so I press next. The name of the exercise I would propose similar name is already there, so I would just shorten it. We will use a default clock configuration. Let's have a look how does it look like. So we will use internal MSI 48 MHz divided by 4. So the system clock will be 12 MHz. We will use the same clock for our interface, so USART and timers. So no change there. Within pinout configuration, I will configure first the PC13 as external interrupt 13 line. And I need to enable interrupt from this, so I will go to system and core NVIC. It is not there, so the GPIO, NVIC, and enable interrupt. The next step would be configuration of timer 14, which we will use in our exercise. So I'll go to timers, timer 14. I just activate it, and I will use this timer in PWM mode, but without signal generation on the pin. As we are using 12 MHz system clock, and we will have 10 Hz signal initially here, so I would propose at the beginning 12,000 minus 1 in the prescaler. In the counter period, I would use 100 minus 1 as we are counting from 0, so 99, and the pulse will be the half of it, so 50. No other components, no other configuration needed. Then connectivity, it will be USART 2, asynchronous mode on PA2, PA3, so no need to change. Within parameter settings, we will keep the default ones, so baud rate 115,000 bits per second, 8-bit data, no parity, and 1 stop bit. The only thing which needs to be done here is a DMA configuration, so I would just add USART to TX, because we need to send some data over USART 2 in circular mode from memory to peripheral, byte in peripheral and the memory side of the communication, and incrementation on memory side. Additionally, we need to enable the synchronization. Synchronization signal would be XT, not here. Here it will be timer 14 output compare, and then signal polarity will be exactly this, and request number it will be 1, because we need to send only one character on each output compare signal coming from timer 14. So that's all configurations for USART 2. We are going to DMA, so again system core, and the DMA we need to enable another DMA channel. It will be our DMA Request Generator, so I just click add, and I will select the first option. It will be again memory to peripheral, so from the one of the buffers in the SRAM to timer 14 prescaler. Circular, this time it will be word. Incrementation on memory side. We will not use any synchronization in this case, but we need to configure this request generator settings. So the signal, it will be our XT13, and the request number, it will be again 1. So that's all configuration. We can generate the project. So I will just click this device configuration tool, code generator. Okay, after the code generation, we can do some code processing. So let's open main.c file. It should be done automatically after the generation of the code, but in case it is not done on your side, please unscroll the project, then find the core folder, and within this src subfolder, please open main.c file. You can use this button over here just to link the file with the Explorer position. So in case you've got multiple main.c files coming from different projects, you can always be sure that you are editing the proper file on your side. Okay, so let's start from some variables declaration. So line 51, within user code begin private variable section PV, and we will declare over here two tables. The first one would be the string, which would be displayed over USART character by character. In our case it will be simple message, but you can use any other one. And the second one will be the table of 3 values, 32-bit long one, which will be used to program the prescaler of our timer 14. And this prescaler will have an effect of changing the speed of displaying the data over the USART. So let's start from the string to be displayed. And the second one, the 32-bit values. Next point would be the activation of the peripherals which we'll use. So as we scroll down, we can see the main function, initialization of the HAL, then system clock, then initialization all the peripherals, which is selected within the configuration phase. And in line more or less 102, we've got the proper area where we can put the activation of our peripherals, and it should be done before the main while one loop. So we'll start from the enabling the request generator, which we configured, so request generator 0 in our case. It is available within DMA library, but it's extended version because DMA multiplexer is not existing in all of the STM32s. So it will be in this extended part. And we've got already the proper function by control space and argument. This is the first one, because the second DMA channel is used for USART 2. The first one is really the DMA generator. Then we need to start a DMA using this generator. So I would use the function HAL DMA start. And then we've got the handler, then the source address. So we need to copy the data from the timer 14 underscore prescaler table to prescaler register of timer 14. So let's start from some casting to be sure that everything will go correctly. Then our table and destination address, it would be really the address of the register. So again, I will start with some casting. Then the address, so like this, and timer 14, and we need to select from the list proper register. Then the data length, it will be 3 because we've got 3 values over there. The next point would be the start of the transmission, the data over the USART using DMA. So we need to select transmit function from USART HAL drivers, the handler of the USART, the buffer name and its size. We can use size of over here. And the last point would be the start of our timer 14 in PWM mode. So as you remember, we configured timer 14 as in PWM mode without any connection to the external pin, but we can use still the activation on the channel 1. So HAL team PWM start and no DMA, no interrupts. We need handler to timer 14 and our channel 1. And that's it. The code part is done. I need to build it using the hammer icon. In the meantime, I can connect my board. Oh, there is some error. So let's have a look. Okay, now it's better. 0 errors, 0 warnings. Now, after the connection of the port, I can start a debug session, clicking on this bug icon. We need a terminal application within this lab, so I will use the built-in one. I will check whether there is no active one from the previous sessions. Yes, there is one, so let me just disconnect and disable it, and I will create a new one just to demonstrate to you how to do this. So before starting the project, let's go below, and within this Open Console button, I click on this down arrow, select Common Shell Console, serial port as a connection type, connection name, I will select something different, let's call it TT, serial port, usually the highest possible numbers as virtual COM port are landing over there. The default settings for the baud rate 115,000 bits per second, 8-bit data, no parity, and 1 stop bit. Let's click OK. And I can see that my TT terminal is already connected, so I can start the application. And I can see that the simple message string is displaying, and I will press the blue button. And as you can see, the speed is changing on each button press. Now is the fastest one, the prescaler has the lowest number. Now I'm changing to once again, so from this 3000 we are landing to 12,000 for inside the prescaler, and I'm changing right now for the middle value and again for the fast one. In case I would like to disconnect from the terminal, I can click on this icon, click again on the connect, will give me the opportunity to connect to my terminal once again. So the lab is ready. You can play with the parameters, change the settings to observe the effect, but as you can see, using this DMA generator, it is pretty easy to connect other peripherals, even if those are not directly connected to DMA. So in this lab, we demonstrated how to connect timer 14 using DMA Request Generator to the DMA and unload the microcontroller and put some more load on the DMA. Further information you can find within different documents. Here I'm mentioning two application notes. The first one, AN5224 STM32 DMAMUX, just about this DMA multiplexer, and another one, bit more generic one, it is AN2548. It is about a DMA controller among different STM32 devices. You can find as well a lot of information about DMA and DMA multiplexer within a dedicated reference manual for STM32C0 family like RM0490. Thank you for your attention.